Right now, the National Oceanic and Atmospheric Administration puts the odds of El Niño fully emerging this summer at 61% and gives a 1 in 4 chance that it grows strong enough to cross a threshold that has only been reached 3 times since modern climate records began, a so-called super El Niño. One professor of atmospheric science who studies this exact phenomenon told researchers just weeks ago that he now estimates the odds of this specific event becoming the strongest ever recorded at roughly 50%, up from the 20%. He was quoting only a few weeks before that. If that sounds like an unusually fast jump for a scientist to make, it is, and it reflects something forecasters have been watching build in the Pacific Ocean since early this year, a surge of warm water pushing east that closely mirrors the exact pattern that preceded the strongest El Niño of the entire 20th century. The record heat that has already gripped large parts of the world this year is not, according to the scientists tracking this, simply this summer's weather. It may be the opening act of something considerably larger, an event capable of reshaping rainfall, drought, and wildfire risk across entire continents for years after the heat itself fades. This is the story of what a super El Niño actually is, why the version potentially forming right now is unfolding in conditions the planet has never experienced it in before, and what the scientists who study its aftermath say could genuinely change, not just for this year, but for years afterward. No hype, no exaggeration, just what the current data and the published research actually say. Drop a comment and tell me whether your region has felt unusually wet, unusually dry, or unusually hot this year, compared to what is normal where you live, because the pattern behind that shift may be considerably bigger than a single unlucky season. I read every one of these. If you want grounded climate coverage built on the actual forecasts and published research instead of recycled panic, subscribe. It is free, and a like helps this reach people who need to understand this before the picture becomes any clearer. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why scientists are treating this specific El Niño differently than the ones that come around every few years, you first have to understand what actually separates an ordinary El Niño from a super one. El Niño itself is a recurring climate cycle driven by warming surface waters in the tropical Pacific, occurring when the trade winds that normally push warm water westward weaken or reverse, allowing a vast reservoir of accumulated heat to spread eastward along the equator instead. A super El Niño is defined specifically as sea surface temperatures, in a key stretch of the Central Pacific rising more than 2 degrees Celsius, or about 3.6 degrees Fahrenheit. Above normal, a threshold crossed only 3 times in the modern instrumental record during the winters of 1982 into 83, 1997 into 98, and 2015 into 16. Further back, before modern meteorological instruments existed, researchers believe a super El Niño in 1876 contributed to a global famine that killed as many as 50 million people. Driven by the widespread droughts and failed monsoons, the event triggered across multiple continents simultaneously. The scientist tracking this year's event most closely, Professor Paul Roundy at the University at Albany, explained that a series of unusually powerful westerly wind bursts moved across the Pacific earlier this year, physically pushing warm water toward the equator with enough force that the resulting pool of warm water sitting off to the east is now measuring about half a degree warmer than the equivalent pool was at the same point in 1997, the year that preceded what was likely the strongest El Niño of the entire 20th century. According to Roundy, the event has essentially already been hit with all the momentum needed to push it past that 1997 benchmark. And he said it would now take a trade wind shift beyond the 99th percentile of anything seen historically to prevent this year's El Niño from becoming extremely strong, rather than merely strong. That does not mean the outcome is entirely settled, since future wind shifts could still partially offset what has already built up. But it does mean a very strong El Niño is now close to certain, with the open question being just how far past that threshold this particular event ends up going. The impacts of an El Niño this powerful are genuinely global, and they rarely take the shape most people expect from a single climate pattern. As Roundy put it plainly, normally wet places tend to become dry and prone to fire, while normally dry places tend to become unusually wet. In the United States specifically, this summer's El Niño influence is expected to bring more rain than usual across the Midwest and West, while a drier stretch settles in from the Gulf Coast up through the East Coast. By winter, as the pattern becomes more firmly established, it typically strengthens the southern storm track, driving East Coast, the same mechanism that made 1982 and 1997 what Roundy described as incredible flood years across the southern United States, while the northern tier of the country tends to run warmer than usual over the same winter months. One of the few silver linings tied to a strong El Niño is a general suppression of Atlantic hurricane activity, since the increased wind shear associated with the pattern tends to tear developing storms apart before they can organize. Here's the part of this story that genuinely sets this year apart from the 3 previous super El Niños on record, and it is why climate scientists studying it are using language considerably more urgent than they have for past events. Global average temperatures are already running more than 1.4 degrees Celsius above pre-industrial levels, and no strong or very strong El Niño has ever previously developed on top of a baseline this warm. Climate scientist Daniel Swain at the University of California's Agriculture and Natural Resources Division said plainly that it would not be surprising to see unprecedented global impacts tied to flooding, drought, and wildfire extremes emerging later this year and into next, and that 2026 or 2027, or possibly both, stand a good chance of setting a new global temperature record. Swain specifically flagged wildfire risk in regions that do not typically experience it at this scale, pointing to the Amazon and parts of Oceania, where peatland fires, once ignited under these compounding hot and dry conditions, are capable of smoldering and burning for months at a stretch rather than being extinguished quickly the way a typical wildfire would be. This is also where the science moves from describing a single intense year to describing something with the potential to genuinely change what comes after it. A study published in Nature Communications in December of last year analyzed all 3 of the historically confirmed super El Niños alongside climate model projections, and found that events of this intensity significantly increase the likelihood of what researchers call climate regime shifts. Abrupt, persistent transitions in temperature, sea surface conditions, and soil moisture capable of enduring for years, or even decades, after the El Niño event itself has already faded. Under continued global warming, the same study found that this effect becomes considerably more pronounced, with the central North Pacific, the Gulf of Mexico, East Africa, the Amazon, Central Australia, and the maritime continent surrounding Indonesia identified as the regions most likely to experience these lasting shifts. The implication researchers drew from that finding is significant. The effects of a 2026 super El Niño may not simply reverse when specific temperatures eventually cool back down, the way past El Niño impacts generally have. Some of the changes this event triggers could effectively lock in. It is worth being honest here about exactly how confident scientists actually are in that conclusion, because overstating it would go against the entire point of covering this responsibly. Roundy himself urged real caution about that specific implication, noting that with only 3 confirmed super El Niños in the entire historical record, the foundation for predicting what reliably follows one of these events is genuinely limited. In his own words, scientists basing conclusions about what happens next on such a small sample of past events should not carry excessive confidence about whether the world is heading toward a full decade of supercharged global warming, or whether this year's effects will simply enhance conditions for a year or so before settling back toward normal. That distinction, a possible decade-long shift versus a single intensified year, remains genuinely unresolved in the current science. And any coverage of this topic that presents one of those 2 outcomes as settled fact is getting ahead of what researchers can currently say with confidence. There is also a slower, less immediately dramatic dimension to how a shift like this plays out, one that researchers say matters just as much as the headline flood, drought, and wildfire risks. Roundy pointed out that ecosystems themselves have evolved alongside El Niño over millions of years, and in some genuine sense actually need periodic extreme events like this one to renew and reset. Certain fish populations, coral systems, and plant communities across the Pacific have adapted over time to cycles of stress, and recovery tied to exactly this kind of event. The concern researchers raise is not that El Niño itself is inherently unnatural or newly dangerous. It is that layering an event of this intensity on top of a climate system already running historically hot removes much of the recovery buffer. Those ecosystems, and the human communities depending on them, have traditionally relied on between extreme events. Roundy was direct about where the real stakes sit, noting that beyond the ecological angle, an event like this carries a substantial human impact, a social impact, and a broader impact on livelihoods that tends to receive far less attention than the meteorological headlines themselves. That human dimension is not simply theoretical, and the historical record offers a sobering, if extreme, reminder of how severe the downstream consequences of a super El Niño can become when a vulnerable population is caught without warning or preparation. The 1876 event, occurring decades before modern forecasting existed to give any advance notice at all, is believed to have driven the widespread crop failures and famine conditions that ultimately killed as many as 50 million people across affected regions of Asia, Africa, and South America, making it one of the deadliest climate-related disasters in recorded human history. Nobody studying this year's developing event is suggesting a repeat of that scale of catastrophe, largely because modern forecasting, irrigation infrastructure, and international food distribution systems simply did not exist in 1876. But researchers do point to that historical case as a genuine illustration of just how far-reaching the downstream effects of a super El Niño can become once its influence on rainfall and drought works its way through global agriculture, which is a large part of why scientists are treating early, accurate forecasting of this year's event as something considerably more consequential than an ordinary seasonal outlook. So what does all of this actually mean for you, wherever you happen to be watching this from? The practical lesson is not that a single, unstoppable, decade-defining climate shift is now locked in and guaranteed, because the scientists who study this most closely are explicit that this remains genuinely uncertain. The lesson is that the record heat, many very likely connected to a considerably larger, still developing pattern, one capable of reshaping rainfall and drought risk across entire regions, well beyond the handful of months any single heat wave lasts, and one unfolding for the first time in the modern instrumental record, against a global baseline temperature already elevated well beyond anything the 3 previous super El Niños ever had to work with. For anyone living in one of the regions, researchers specifically flagged as most exposed to a lasting shift, including the Gulf Coast, East Africa, the Amazon basin, and the broader region around. Indonesia, that means treating this year's extreme weather less as an isolated event to simply wait out, and more as a signal genuinely worth tracking as the pattern continues developing through the rest of this year and into next. The honest, grounded summary is this. NOAA currently puts the odds of El Niño emerging this summer at 61%. With roughly a 1 in 4 chance it strengthens into a super El Niño, a threshold reached only 3 times since modern records began. The scientist tracking the event most closely has raised his own estimate of it becoming the strongest ever recorded from 20% to 50% within just a few weeks, based on westerly wind bursts already measured as more powerful than the ones that preceded the previous record holder in 1997. This event is developing against a global temperature baseline more than 1.4 degrees Celsius above pre-industrial levels, a combination that has never occurred before in the modern record, and published research analyzing all 3 prior super El Niños found that events this intense significantly raise the odds of lasting climate regime shifts capable of persisting for years or decades in specific vulnerable regions around the world, even as the scientists behind that same research caution that, with so few historical examples to draw from, real uncertainty remains about exactly how long or how severe those lasting effects will actually turn out to be. We are going to keep tracking this exactly the way we tracked it today, straight from NOAA, the researchers actually studying this event in real time, and the published science on what past super El Niños have left behind, not recycled panic headlines. Subscribe so you do not miss how this event develops over the rest of the year, because based on everything we just walked through, this is very likely still in its early chapters. And leave that comment below. Tell me if your region has felt unusually hot, wet, or dry this year, because the pattern behind that shift may be considerably larger than any single season. Because behind every one of these probability numbers is a farmer in the Gulf Coast region watching rainfall totals that no longer match what used to be normal, a community near the Amazon bracing for a fire season, unlike anything their region has dealt with before, and a group of scientists who are genuinely uncertain and genuinely honest about that uncertainty, regarding just how much of what happens this year is here to stay. 5,000 likes on this one. Let us go. See you in the next one.